So you are looking at probabilities. We looked at binomial. We also looked at Poisson. So today, so we solved some questions of Poisson. So then today we look at exponential probability distribution. Exponential probability distribution. Exponential probability distribution. There's a name. So you can write that this is a continuous probability distribution. This is a continuous probability distribution used to study the distribution of service time. The distribution of service time in such areas as hotels, hospitals, etc. First of all, it is also used to measure. It's also used to measure the usefulness of some items such as bulbs. First of all, where the examiner wants this distribution to be used, there must be mention of the word exponential. There must be mention of the word exponential. The formulas used are probability that t is greater than or equal to small t is E by that way. Probability that t is less than t small is 1 minus E. And the probability that we have t1, t2 here is E that way, where t is service time, U is 1 out of mean service time, and E we know is 2.7182. So read for us question 1. Question 1 in the adult. Not question 1, this is number 1. What? As an exponential. 20? 24.
Suppose anomaly distributed random variable x has meaning is that and standard deviation at 7.
But not that one. Under the exponential. The exponential distribution.
The time taken by a cashier in certain bank to serve customers is daily. Follow an exponential distribution determining 15 minutes. Determining the probability that customer will be served for a period of at most 10 minutes.
Okay, so the first thing is in answering that question number 20 is to know the mean time. So we know that the mean time is what? The mean time is 15 minutes. So they are taking 15 minutes to serve. So if they are taking 15 minutes to serve, then our U will be 1 out of 15. Our U will be 1 out of 15. Haya. Tumeulizwa the probability that it will take at most 10 minutes. So if you are told at most, it means T is less than or equal to 10. So this will be simply 1, according to the formula that tumeweka hapa, for less than or equal to is 1 minus E raised to minus 1 out of 15 times 10. So you can either go direct in using the calc, or you can do what we were saying, 1 minus 2.7182 raised power minus 1 out of 15 times 10. The answer? Zero 0.48. 4865. Okay. The next one is you are told what time?
Between 12 and 20.
So if T is between 12 and 20. So this is E raised power minus 1 out of 15 times 12 minus E raised power minus 1 out of 15 times 20. So this one can become 2.7182 raised power minus 1 out of 15 times 12. You minus 2.7182 raised power minus 1 out of 15 times 20. Zero 0.731. Okay. 731. The next one is probability that
More than 18 months. That's 0.731. It is supposed to be 0.186.
0.186.
More than 8 minutes.
More than 8 minutes. So T is greater than or equal to 8 minutes. So hii ndio tumesema it is simply E raised power 1 out of 15 times 8. So this becomes 2.7182 raised power minus 1 out of 15 times 8.
Minutes.
0 point.
Minutes.
587. What's up, eh? Okay. So I believe you can be able to handle the others, eh? Because the key thing is just to know the mean and then the formulas. Is that okay? So if that is fine, let's then move to the next distribution, which is the most. This distribution is very rare nowadays because it used to be used in a topic called queuing theory, and that topic has since been removed since 2020. Sijui hata kwa nini walibakisha hii distribution, because the main topic where it used to be used, the topic was removed. We used to study a topic called queuing theory. So we are going to talk of normal probability distribution. Normal probability distribution. Normal probability distribution, right? That this is a continuous probability distribution. This is a continuous probability distribution. It's a continuous probability distribution that is used to determine the probability of a small interval. That is used to determine the probability of a small interval. Probability of a small interval. Stop. It is used where the mean is 0. It's used where the mean is 0 and the standard deviation is 1. The mean is 0 and the standard deviation is 1. if these characters are not satisfied, the values are standardized. Using the formula z is equals to xi minus x bar. You divide by standard deviation. The values are standardized using the formula z is equals to xi minus x bar divided by standard deviation. When we write that the computed value of z, stated in two decimals, is used to obtain the probability of the interval between xi and x bar. Interval between xi and x bar. From the normal curve table. As you can just write from the normal table. The normal curve is as follows. The normal curve is as follows. So we have x bar here, which is 0. We have standard deviation, which is 1. Then we have this one is 0.5. This one is also 0.5. And you see, it's not touching the x-axis. They're not touching the x-axis here. This one's yeah. Okay. So let's get to the questions. Now, in the questions, I think we had read last question, question number 1. Or rather, question 21 now, Oh, it's 24 now. So with that question, question 24. Now, we are Roman 1, we get probability that x is what? Greater than 23. So probability that x is greater than 23. So if it is greater than 23, what you do, you draw a small table like this. A small table like this. Then here you put the mean X bar, which is tumeambiwa the mean is 20. 30. The mean is 30. And then the standard deviation is what? 7. Sasa 23 iko on the lower side hapa. Hapa ni 30, 23 must be somewhere here. So X1 here is 23. So when you're told greater, you want the higher side, right? So you shift this that way. So, the next thing you do is to get Z. We call it Z1. Z1 is given as X1 minus X bar. You divide by standard deviation. So this will be 23 minus 30. You divide by 7. You divide by 7. That gives us minus 1. So it's given as minus 1.00. Yeah, because the value of Z is stated in 2 decimals. Then you say from the tables, we are going to have the normal tables. Go to your past papers, commission. Your past papers at the end, you look for the normal curve. You can see it, eh?
Recording in progress.
Okay. So if you have seen that table, you have seen that table. I'm saying that table inakaa namna hii. On this side, we have some values that are starting from 0.0, so all the way to 3 point what? 3.9. Then on this side, we have values that are starting 0, 1, all the way to what? 9. Then huku ndani, we have values that are to 4 decimals. So what you do is, ukishapata this value of Z, whether it is positive or negative, you come and look for it here. The first one decimal this side, the second decimal this side. Like now that this one you have got 1.0, utakuja mahali kumeandikwa 1.0, alafu column 0. Nisomee who is there. Which value is there? 0.3413. Now that 0.3413 is the probability from your xi or your x1 to x bar. So hii ni probability kutoka hapa mpaka hapa. But we have said that kutoka hapa mpaka huku mwisho, it is always 0.5. And because we also want the other side, then you say plus 0.5. That gives us 0.8413. 8413. The next one, Nabiwa.
X is less than 20.
X is less than 20. So if you are told or you are looking for probability that X is less than 20, X is less than 20, X is less than 20, again, you draw that table here. And you tell us here, X bar is 30. So less than 20 is here, X1 is 20. So we are looking for the lower side because we are told less than eh? So we are looking for the lower side. Then the standard deviation here is 7. The standard deviation is 7. So if you have done that, you now come and tell us Z1 should be equal to X1 minus X bar. You divide by standard deviation. So this will be 20 minus 30. You divide by 7. 20 minus 30, you divide by 7 is what? Negative 1.428. Huh?
1.428.
So we can make it 43. The values of Z are always given to 2 decimals. So then you tell us from the tables, probability that X is less than or equal to 20 will be equal to 0.5 minus 0.5 minus. Sasa utaenda mahali kumeandikwa 1.4 hapa and column 3 where they meet. 1.4 column 3 where they meet. Nisomee what is there.
And 4236.
4236. Now this 4236, this 4236 is always the probability kutoka hapa kwa x1 mpaka kwa x bar. So hiyo ni probability ya hapa. But you see that is not what we want. Tunataka the lower side. Lakini tunajua kutoka hapa kwa x bar mpaka huko mwisho ni 0.5. So tutoe hii yenye hatutaki 0.4236. So that now we are left with the one that we want. Zero point zero 64. 0.0764. Okay. The next one is what?
X is between 32 and 40.
X is between 32 and 40. X is between 32 and 40. So hapa unakuja unasema this is where we have X bar, which is 30. So that 2 should be somewhere here, X1, that 2. And then we have X2 here, which is 40. So in between there. So X is between 32 and 40. And the standard deviation, the same, you say it is 7. So what you do from there now is again Z1 as X1 minus X bar, you divide by standard deviation. So this will be that 2 minus 30, you divide by 7. That 2 minus 30, you divide by 7. 0.29. Z2 is X2 minus X bar. You divide by standard deviation. So this will be 40 minus 30, you divide by 7. $1.43. So from the tables, probability that we are between that 2 and 40, that's 2 and 40. So this is how you look at it. When you will go to read 0.29, it will give you the probability ya kutoka hapa kwa 30 mpaka 32. It will give you the probability ya kutoka 30 mpaka 32. Then when you go to read the probability of 1.43, that will be the probability kutoka 30 to 40. So for us to get the one that we desire, itabidi tuchukue hii yote, then we subtract this one. So nisomee hii ya 1.43. 1.43 is 0.4236. Now that 4236 is the probability kutoka 30 mpaka 40. Then we need to read the one of that to that 2. So 0.29. 0.29. 0.1141. Zero point 9 5. Yeah. The next one.
27 and 10. .
X is between 27 and 35. X is between 27 and 35. So if X is between 27 and 35, we have X bar here, which is 30. Standard deviation, which is 7. 27 is on the lower side hapa ndio kuna x1 27. Alafu on the upper side here, x2, we have 35. So you are going to shade this way. So kama tume shade, again we embark on getting our Z1, which is x1 minus x bar, you divide by standard deviation. So this will be 27 minus 30, you divide by 7. 27 minus 30, you divide by 7. Let's graph negative 0.43. Okay. Then Z2 is x2 minus x bar. You divide by standard deviation. So this will be 35 minus 30. You divide by 7. Point 71. So from the tables, probability that we are between 27 and 35. 7 and 35. It is again now, kiangalia hapa, hebu nisomee hii ya 0.43. 0.43. 0.1664. Haya, nisomee hii ingine ya 0.7. 0.71. 2612. Sasa angalia hapa. This one of 0.164 yenye tumepata from this 0.43 is the probability from 27 to 30. And this one is the probability from 30 to 35. So for us to get our desire of 27 to 35, you simply add the two. Simply add the two of them. Points? 4276. 4276. 4276. 4276. Good. The next one.
X is greater than 34.
X is greater than 34. X is greater than 34. x is greater than 34. So if x is greater than 34, we are going to have something like this. X bar here is 30. Then we have x1 here, which is 34. Standard deviation here is 7. So Z1 is equal to x1 minus x bar, you divide by standard deviation. So this will be 34 minus 30, you divide by 7. You have 0.57. So from the tables, probability that x is greater than 34. Haya, sasa ukienda kwa table unisomee 0.57. Utapata nini? 0.2157. So this is how it is explained. This 0.57, it is giving us this probability. The probability is between 30 and 34. Between 30 and 34. So if it is between 30 and 34, so you subtract. Two eight four 0.2843. That's all. Okay, then we go to the next question. Kama hiyo tumemaliza. Nasema nini?
Invoice at a particular report file amounts which follow a normal distribution in the mean of 103.6 units and a standard deviation of 8.73 units, determining the percentage of invoices that will be over 120.
Okay, so the invoices that will be over 120.05. So over 120. So once again, you just do your normal table. Just do your normal table. And in doing this normal table, you have X bar. The mean to me be 101. 103.6. And the standard deviation is 8.7. 8.73. So ukiambiwa we want over 120, iko na huku tu hapa. So this one, X1 is 120.05. So this is what we want. So if that is what we want, Z1 Z1 is 120.05 minus 103.6. You divide by 8.73. $1.88. 1.88. So from the tables, probability that X is greater than 120.05. So hii nimekuambia kienda kwa table kusoma tutapata from here 103 to 120, but we want the higher side, so we must say 0.5 because yote kutoka hapa mpaka mwisho ni 0.5, so that we subtract what we are going to read. So what we are going to read is what? 0.4699. 0.4699. 0.4699. 0.0301. 0.0301. Okay. The next
below 7.75.
We are below. Umesema 72.75. So once again, we draw our table. There's a small one to illustrate that this is X bar here, and this X bar is 103.6. 72 is here. X1 72.75. So below is on this side. And the standard deviation here is 8.73. 8.73. So Z1, si lazima ushinde ukirudia formula, nimeandika sana now. By now you should have gotten it so well. Minus 103.6. You divide by 8.73. Negative 3.53. So from the tables, probability that X is below 72.75, it will be 0.5 minus 0.4998. So when you subtract
0.000.
how many zeros? 3. Okay. Na tulikuwa tumeulizwa percentage, So these ones, if you want them to be percentages, you simply multiply by 100. Eh? Yeah. Like now, if you multiply by 100, itakuwa 3.01%. Eh? Na hii nayo multiply by 100, itakuwa 0.02%. So when they ask for whatever you the next one, unaulizwa nini?
Between 23.65 and 117.6.
Between 83.65 and
17.6.
hebu jaribu kufanya hiyo nione. Ungaona? Jaribu ungaona. You finish. Z1, you should have said 83.65 minus 103.6. You divide by 8.73. Ukapata? Negative 2.29. Then Z2, ukasema 117.6 minus 103.6. You divide by 8.73. Ukapata? 1.60. So when you went to the table, ukasoma hii, ulipata ngapi? 0.4? 4830. 4890. Na hii nayo imekupea nini? 0.4452. So when you add them, 0.9342. Yeah. Nakubaliana? Yeah. Okay. We go to the next one. The next one unaulizwa, they are between what?
What will be the invoice amount such that approximately 25% of invoices are for greater amounts?
Such that the invoice amounts. So amounts of invoices we are told such that 25% are for greater. So what you do, you again get here 103.6. Then standard deviation here is 8.73. So kama wanasema greater amount, it must be on this side higher. This one. Na hii sasa hii x1 ndio hatujui. Lakini this area hii nayo ndio tunaambiwa it will be 0.25. 25% to be of greater amount. So having done all what we have done, when we are presented with this question, we know that there is a formula says that Z1 is equals to X1 minus X bar. You divide by what? Standard deviation. So the value that is missing in our equation here is this X1. Na iko kwa hii formula. So we make it the subject. So in making this one the subject, hii inakuja huku ndio tunaachwa na standard deviation Z1 is equals to X1 minus X bar. And therefore, X1 will be X bar plus standard deviation Z1. When you make X1 the subject. Sasa, we already know X bar, we also know standard deviation, What we do not know is Z1. Z1. Now, Z1 is what we had arrived using this formula. But now we cannot use it. But we know when we were doing it, wakatulipata hii Z1, tulienda nayo kwa table. Ikatusaidia a value that we subtracted from 0.5, ndio tukapata hii. Unakumbuka hiyo? So we are going to say now 0.25 hii it was obtained as 0.5 minus value obtained from the table. Is a value we had obtained from the table. So if that is true, then value obtained from the table should be 0.5 minus 0.25, and that would be 0.25. So that value that was obtained from the table must have been 0.25. From the tables, Z1 should then be equal to Sasa, there's something I want you to see. If you look at all those questions that we have done, anytime x1 imekuwa on the lower side of x bar, the value of z imekuwa negative. So, now anytime the x1 is on the higher side, the value of z is what? Positive. So that should tell you, because our table does not tell us who is positive and who is negative, you should now have in mind that your value as z itapata will it be positive or negative. Because you know that kama iko on the lower side, it's negative. Kama it is on the upper side, it is what? Positive. Sasa ukiangalia hii table yetu, are we on the higher or the lower side? The higher side. So we expect a value of z which is positive. Sasa tunakumbuka mahali kama tulipata hii hiyo 0.4998 tulipata huko ndani. Ukienda huko ndani, kwenda mahali utaiona kwa table zako hii 0.4998 unaiona. Sasa ukishaiona, usome the value that is on this side, the row. Hapo kwa row tuko na 3.5. Sawa. Na huko kwa column ni 3. So uki 3.5 na huko juu tuko na 3. So in the same understanding, can you now read for me 0.25 huko ndani? Now as you go huko ndani, you may get it exactly, the value that you are looking for, or you may not get it exactly. If you do not get it exactly, you pick the value that is closer to it, either slightly higher or slightly lower. So nataka uingie huko ndani tutafute 0.25. Ile value imekaribia 0.25. That is the closest. Nimesema you take either slightly higher or lower. Either will work. 2486, eh? Now hiyo 2486. Haya, niambie huku kwa kando iko na kwa row 0.6 na kwa column 7. That's how you get the value of z. So if you have gotten it that way, then unasonga mbele, unakuja unasema thus x1 is x bar, which we know 103.6 plus standard deviation, which is 8.73 multiplied by 0.67. So that is the invoice amount, 109.45. So hiyo ndio inaitwa sasa kurudi reverse. Zenye tulikuwa tunafanya zote zilikuwa forward. Sasa unarudi reverse. Haya. So hii formula tutakuwa tunashinda tukidevelop hivi, tutaishika hapo. The next one unaulizwa utuambie the invoice amount such that they are symmetrical. Symmetrical 95% about the mean, eh? So ukiambiwa about the mean, symmetrical kwa namna hii. This is the mean. Mean ikumbushe ni 103 point what? 0.6. Na standard deviation tumesema ni 8.73. So when they are saying it is symmetrical, something is called symmetrical if it can be divided into two equal parts. It can be divided into two equal parts. So the whole of this tunaambiwa ni 0.95, 95%. So kama it is symmetrical, ni kumaanisha hapa ni 0.475 na hapa ni 0.475 again. So this one is x1, which we do not know. This is x2, which again we do not know. Tutakuja hapa tuseme x1. Tumesema ni x bar plus standard deviation z1. Going by what we have developed in the other. So value obtained from the table. Value obtained from the table. Now this one is direct. You're here. 0.475. So here I'm going to subtract. That one was read from the table. Thus, Z1. Sasa utaingia huko, and before we ingie, you must know whether that Z will be positive or negative. So what will it be? It will be negative because tuko na huko chini, eh? So it will be negative. Sasa ingia huko ndani kwa table, utafute hii 0.475. Ona kama utaiona huko ndani. $1.96. Z at 95% is 1.96. Hiyo lugha utakuwa unaisikia sana as we go by the time. So the negative 1.96. So then it means that our x1 should be x bar, which is 103.6 plus 8.73, which is multiplied by negative 1.96. 86.45. .49. The 6.49. Okay. Then x2. Here the two are the same argument. It will be our x bar plus standard deviation z2. So this one, the same value obtained from the table. Value obtained from the table is 0.475. 0.475. Thus, Z1, sababu zinafanana, the only difference is whether it's positive or negative. So is that positive or negative? So it will be positive 1.96. So my x1 then will be 103.6 plus 8.73 times 1.96. Huh? 20.71. 20.71. Okay. See, tunaelewa. Let's omit the next question. I still have like 10 minutes.
The Western National Bank is reviewing its service charges and the interest paying policy on current account. The average daily balance on personal current accounts is 5,500 with a standard deviation of 180. In addition, the average daily balances are normally distributed. The bank is considering paying interest to the customers carrying average daily balances in excess of a certain amount. If the bank does not want to pay interest more than 5% of its customers, determine the minimum daily balance it should be willing to pay interest on.
Yeah, the bank does not want to pay interest more than 5%. So, first of all, the mean is what? The mean balance. 5,500. Now, standard deviation is 150. Sasa, wale wanalipwa interest na bank, wale wako na pesa mingi ama wako na pesa kidogo kwa account. What? All of them. Hata ukienda uwekage shilingi 2 kwa account yako, the bank will give you some interest. Eh? Who do you think will be paid? Yes. You people, do you have bank accounts? Mwaenda ukapata account yako imeongezeka kidogo. Nonetheless, it's a fixed interest account. Sindio? Yeah. Because after some time, sasa hiyo ita accrue. But kama ni hii current account, hii savings account, you are still on the lower side. So wale wako na pesa mingi ndio huwa wanalipwa. Yeah, so that is the knowledge that's why now hii maswali inaitwa application. Sasa hiyo ni application. So kama ni hivyo, then hiyo x1 tunatafuta iko hapa. Na hatutaki hii ikuwe more than what? More than 0.05. And with that, we already now know hii itakuwa ngapi? Hii si itakuwa 0.45. Si kuanzia hapa mpaka mwisho ni 0.5. So hii imebaki, ndio ninasema 0.5 minus 0.05. Kwa sawa. So we will say that value obtained from the table, value obtained from the table, hiyo hii nimesema ni 0.5 minus 0.05, which is 0.45. 0.45. Z1. Now that we are on the higher side, it will be positive. See there? So go to the tables. Utafute hii 0.45. You may not get it exactly. Pick the closest. So hiyo itatupea value ya Z ya 1.64. So if it's giving us 1.64, we know that x1 then should be x bar plus standard deviation Z1. So sasa hii nayo inakuwa 5500 plus 150 times 1.64.
What is it? 57, what is it?
Yes. But language is quite, yeah, it was out.
Yeah, it's okay. It's okay. Yeah. It depends on what you think is closer. That's actually some people even will subdivide. So now like hapo katikati. So instead of using 1.64 or 1.65, sasa unatumia the median 1.645. They are approximations. Naona hii kitu yenye kaigusi hapa. Hiyo ndio inaleta hiyo makosa. Yeah. But if you want it to be exact, we use calculus. There is a way we differentiate, we integrate the function. But it's very interesting. We don't teach it at the level. So at this level in the record, we call it as symptotic. Good. Sasa, practice those questions. And as I have said, there is almost a guarantee that your exam will have a question or no. And actually more than one, because normal is applicable in many topics. So wanaweza ileta ikiwa independent kama topic, kama probability, ama wailete kwa other areas. Yeah. And as I said, as we go by, the answer one, especially to kwa hypothesis testing, this knowledge are very important. So guided practice kabisa your normal, it is very, very important and it's applicable not only in QA, even in other areas as well as you will be finding normal distribution. That's why you need to know kitu normal kitu ya kawaida. Yeah. Thank you. We call it at that point.